We have seen the dot product. Now let's look at the cross product. So let's say we have a vector A, vector B, and as usual we do a projection of B on A. Now in case of dot product, we saw that A dot B is equal to magnitude of A, magnitude of B cos theta. The other possibility is what? If you just randomly just think about it without any reason. The other possibility is that instead of cos theta, we will have sin theta. But if we think in terms of sin theta, what happens? Sin theta is going to be opposite side by hypotenuse. That means this part, so let's say O, B, A, OA, OB, and let's say this is M. So BM would be the opposite side. But how does this help us? One way of looking at it is, okay, since we have the cos theta, so that means cross product is something that we can say is magnitude of A times magnitude of B sin theta. Just like that. We can say that. But what is its significance? How would you think of it? A lot of things we come out with just because of thinking like that. Okay, we have something called as a dot product that uses cos theta. So there must be something which uses sin theta. And to that we give a name called cross product. So if you complete the parallelogram, you will notice that this BM is the height or altitude of the parallelogram. Magnitude of A times BM is going to give you the area, right? Area of the parallelogram. So let me just keep writing it. So OA is equal to A, OB equal to B, this is C, AC is parallel to OB, and AC is equal to OB. Similarly, OA, we can take all these as vectors. OA is parallel to BC and OA is equal to BC. Now, because we have said we are going to, instead of looking at this part, that is the adjacent side, we are going to look at the opposite side. We look at the sine of theta. Sine of theta is going to be BM by OB, and the side that we are actually interested in is equal to OB sine theta. And as I mentioned, OA is the base of the parallelogram and BM is the height of the parallelogram. So in a way, OA times BM gives you what? The area of the parallelogram. Area of the parallelogram is equal to, now OA is what? OA is magnitude of A and BM is magnitude of, say OB, let's say B sine theta. Now this is area of something is something important. So when we say here area, we are not necessarily only talking in terms of the geographical area. The result is going to be a vector, which means this actually gives us the magnitude. So the direction, one thing is clear, it can't just be in the direction of A. it can't be in the direction of B. Direction is perpendicular to both A and B. Magnitude would be the magnitude of A cross B. Therefore, now we know that A cross B is equal to magnitude of A, magnitude of B, sine theta in the direction of the normal to both the vectors. So n cap is perpendicular to A and B. Now if you look at only OAB, that is a triangle, right, which is half of the parallelogram. So area of triangle OAB would be equal to half of the magnitude of the cross product. Now let's look at some properties of cross product. A cross B is a vector. Magnitude of A cross B is equal to magnitude of A, magnitude of B, sine theta. Direction is along n cap, which is perpendicular to both A and B. Now B cross A is equal to what? B, magnitude of B, magnitude of A, sine theta times minus n. Direction has changed. This would be, we bring the minus in front. Now this part is anyhow commutative. Yes, whether you write magnitude of B times magnitude of A or magnitude of A times B, doesn't matter. So A times B sine theta n cap. Now this part is nothing but A cross B. Cross product is not commutating. So the order of multiplication matters. Okay. Now if theta is equal to 0 or theta is equal to pi, that means what? That both the vectors are collinear. So A cross B would become what? If it is 0, it will become magnitude of A, magnitude of B, sine 0. Sine 0 is 0, so the whole thing will become 0. Now, if it is pi, then in that case, A cross B will become equal to magnitude of A times magnitude of B, sine pi. Sine pi is again 0. So that means A cross B is 0. So therefore A cross B is equal to 0 if theta equal to 0 or pi. Now if it is the same vector, that means two equal vectors and in the same direction, A cross A, sorry, not B, A vector A cross vector A, this would also be equal. Okay. Fourth one. Now if A is perpendicular to B, we looked at theta equal to 0. Now we are talking of perpendicular. That means theta is equal to pi by 2. A cross B would be equal to magnitude of A, magnitude of B, sine pi by 2. Sine pi by 2 is 1. So this would become, let me also put n cap. So magnitude of A, magnitude of B in the direction of the normal. So now that we have seen the third and fourth property, that we can use I cross I is going to be what? A cross A is equal to 0, remember? So I cross A, J cross J, and K cross K. I cross J would be equal to, now remember here, the angle between I and J is 90 degree. They are perpendicular to each other. That means the result will be perpendicular to both. And that is nothing but K. K times I is equal to J. J times K equal to I. The best way to remember this is, remember we are going circular, right? So let's say this is I and J and this is K. So if you are going from I, if you are saying I cross J, you get K. J cross K, you get I. K cross I, you get J. Clockwise direction. Now, what about if it is opposite? Remember, they are not commutative. So if we say J cross I, it would be negative K. I times K, it would be minus J. And K cross J would be minus I. So in this case, go in the opposite direction. The only thing that is changing is the direction. I, J, K. This is J. And put a negative number. So J times I gives you minus K. I cross K gives you minus J. K cross J gives you minus I. Now, what about this? I cross J. This would be I cross, first we have to take care of this. I cross J is K. And I cross K is minus J. Now, if we take in this order, cross J, then I cross I is 0. Cross J, which is equal to 0. So, which means cross product is not associative. Okay, next. Now, if you look at A cross B is equal to magnitude of A, magnitude of B, sine theta n cap. Now, which means A cross B is a vector along vector n, or unit vector in the direction of the unit vector n. This is perpendicular to both A and B. So, which means A cross B divided by the magnitude of A cross B would be what? Would be a unit vector along A cross B. So, which means n cap is also A cross B divided by magnitude of A cross B is also a unit vector perpendicular to the plane of A and B. Remember, minus n cap is also a unit vector perpendicular to both A and B. So think of it like this. A and B are this. They are lying flat, and this is your n. If we are above this, it is positive. If it is below this, it is negative. Okay. Now, magnitude of A cross B would be what? Would be the magnitude of A, magnitude of B, sine theta n cap. Now, Magnitude of A is magnitude of A, so no issues. Similarly, this also is magnitude. Sin theta is a number, so it is only magnitude. But n cap, remember this is a unit vector, perpendicular to both A and B. Its magnitude is 1, so 1. So we don't have to write it. So therefore sin theta would become magnitude of A cross B divided by magnitude of A, magnitude of B. Now A vector A cross vector B plus vector C is equal to, it is distributive in nature, so A cross B plus A cross C. Let's say vector A is A1I plus A2J plus A3K, and vector B is equal to B1I plus B2J plus B3K. So A cross B would be distributed. Remember, it is distributing. Now this would be A1 B1 0. Why? Because I cross I is 0 plus A1 B2 K plus A1 B3 minus J plus A2 B1 minus K plus A2 B2 0 plus A2 B3 I, A2 B plus A3 B1 J plus A3 B2 minus I plus A3 B3 0. Now this would be equal to A2 B3. We are looking at I, A2 B3 I minus A3 B2 plus, now J, where is J? J is here. A3 B1 minus A1 B3 plus, now K, A1 B2 minus A2 B1 K. Right? If you notice, it's quite remarkable, and if you are able to relate to some other part of mathematics, you are multiplying something with A2 B3 and the difference between A2 B3 and A3 B2. This somehow looks very similar to what happens in matrices, right? And if you go back and refer to it, you will realize that this is nothing but the expanded form of the determinant. So I, J and K, A1, A2, A3, B1, B2, B3. Now let's evaluate the determinant. I times A2 B3 minus A3 B2. Similarly, minus J times A1 B3, right, minus A3 B1. The order is reversed, but outside it is minus. So we make this plus and change the order of this. So we get A3 B1 minus I1 B3 plus K times A1 B2 minus A2 B1. So that is A cross B in Cartesian form. Okay, so that is vector product. That's it for today. Bye for now.